Okay, folks, this is Dr. Hyman, and I have given portions of this talk previously, but there's a lot of new information, a lot of updates, and so I'm going to go a little quicker because there's a lot of slides, and I want to make sure that I'm doing everything I can to get to the information, maybe in a little less time. So I apologize now in advance if it goes a little fast. It's going to feel like you're drinking from a fire hose. But the good news is you can always pause me, go back and look at everything and then decide if this really works for you or what information I said, and always happy to clarify. But what I'm trying to do is get information to everybody as it evolves, because we all know how difficult this information is right now, in order to try to get it out to everybody, to make sure everybody's clear and aware and certain of this. Okay, so okay, here we go. All right, so you know that I have disclaimers for my talks. As you know, I always give thanks to the people that help me out. Also give thanks to my boys for their help. And also, I always give conflicts of interest because I never know if some of these books are going to be brought up, or if people are going to look at the books and say, oh, I got this from his talk. So just to remove that conflict of interest. I've also got comments in some of the national guidelines I've written. These are some of the articles that have been published in the medical literature that are also available for people to go and take a look at and decide if there's any information that might be of help. Okay, so remember the agenda here: brief history, some testing immunology, and then the current experience, which is going to be the real focus of this update information for everybody. Okay, so remember we had discussions previously about what's an epidemic, what's a pandemic, and what some of those different criteria are when you get involved in large types of people. Again, on the history, there was a lot of discussion about the whole source of these particular viruses and where did it come from, how did it get to us, and there is a timeline of some of this information, and this gives you an idea of some of the timeline and why. There's been a lot of discussion about how did this happen. The most likely thing right now is indeed the gain of function research, which is paid for by the U.S. under Dr. Fauci, led to a lab leak. That's just the way it is. Not trying to take sides or anything like that, but just trying to be honest that what seems to be the best information right now. Because people always ask me, well, how did this happen? Where did it come from? That seems to be best. Again, willing to change things anytime, for sure. And there's some of the family on a rest stop. Okay, again, I want to remind everybody this is so important. All you read about, antibodies, vaccines. What you don't hear about is the importance of cellular immunity, the T cells and B cells, which fight these infections. These infections are being fought by our cellular immunity. Keep that in mind because you don't hear a lot about that, right? The blood test that looks for those antibodies is addressed towards the protein envelope, which is the spike protein. And this gives you an idea of when you start to see those antibodies. IgM 4 to 6 days, peaks at 12 days, declines after that, IgG 10 to 18 days, right? And then in the past outbreaks of SARS and MERS, there were clear evidence and documentation of persistence of some of those. So when we look at a typical curve of blood testing the blood, the antibodies, right? So here you go, you get involved with an exposure, right? Here you're exposed. And then all of a sudden, if you were to test the PCR, which is the test of the nasal smear, you'd start seeing some evidence of virus, right? Symptoms come right here, usually 4 to 6 days, about a week on average maybe, and that's when you know that you're going to have the symptoms start, but you've already got those virus being shed, you've already got ability to isolate it, and what you see here is that the antibodies start here, right? See those dotted lines of the antibodies? So that's when you get what's called antibody detection, right? And that's the time frames to always keep in mind about these things, right? And then again, I've mentioned to you before why I think it's so important to remember the T cells and B cells, because there's good data about prior studies that showed that you can have T cells and B cells from prior exposures, right? And that those will persist and are an important part of the cellular protection, right? And then this particular study and some of the other work from Shane Crotty's lab in San Diego, they're showing you that even people that never had the SARS-CoV-2 have some antibodies because this overlaps with a lot of other coronaviruses that we've been exposed to. So another way to look at that natural immunity is the T cells, B cells, right? Here's week 1, week 2, week 3, and all of a sudden you start seeing this rise and the peak of the memory B cells, right? And you see where the IgM, IgA is definitely in place around week 4, and IgG really peaks around 7 weeks, right? So it gives you an idea of both the cellular and the antibody immunity and the time frames involved. And when we look at the literature, you're going to see all kinds of things like this. Don't let the curves get to you too crazy. What they're just showing you is the persistence of the antibodies over time and how we're able to document this over periods of time in different people. And yes, there is a little bit of drop off of antibodies that does occur, but in general, these responses are quite robust, okay? So the antibody levels will lower in asymptomatic people. They may drop quickly, but even if you're reinfected, there is always going to be less illness. The durability is now verified for at least 18 months. Not all antibodies fight the infection. Some can even make it more permissive, depending on how they attack the spike protein. This is a very interesting piece of science, where depending on the antibody attacks the protein, sometimes it changes in a certain way that could even make infection more likely. So not all antibodies are great, right? Now, another thing I want you to remember, people say, oh, antibody levels, they're dropping, they're dropping, they're dropping. Look, there's good literature. Look. You only need about 3% of neutralizing antibody to present severe infection or death, right? Keep that number in mind, right? When they start there, well, it dropped. Yes, but there's still a lot of protection that goes with it, right? The lab methods used to claim efficacy for a vaccine have many methodologic variations, so it's hard to compare them, right? Neutralizing antibody levels are predictive of immune protection, and we'll talk about that in the third dose. At least 90% of people develop antibodies after the natural infection, right? So natural infection is going to be a good way to go for a lot of people, right? Okay, rest stop. Now, reminder on some things we talked about before. The types of viruses. Remember this? We talked about this. Look. The inactivateds, the recombinants, the viral vectors, the mRNAs, right? Those are some of the ones that are in different types. So we've always had different ways of looking at how we can develop vaccines to go after different particular organisms, right? And this looks at the procurements from the different companies of these vaccines for the coronavirus, right? Now, the one that everybody talks about, the mRNAs, Pfizer, Moderna, okay, remember they started as EUA, right? Emergency Use Authorization. Well, now they're getting actually full approval, right? So this is shifting over, right? And it's telling you the progress that we're making on these vaccines, right? Now, remember, please remember this, right? You always have to distinguish. A vaccine will prevent disease, not infection or asymptomatic viral shedding. So in other words, if you get the vaccine, you're going to do much better, right? You could still get a little sick. And there's a rare person, we'll talk about that later, that could actually get into big trouble. But the vast majority of people do very well with these vaccines, right? Now, how do we know how they're doing? We have different systems in the United States. We've talked about this before, the different ways that we have in the United States of tracking for those side effects, right? So the VSafe, that was the one with the smartphone, right? Where you get a text message from the CDC, right? And then people actually are volunteering to be checkers and volunteering to talk about what they're doing. Did they receive medical care? How's their health? And that's something that can be used to look for trouble, right? VAERS, you're going to hear a lot about this one. This is very much in the literature, right? And it's an early warning system co-managed by CDC and FDA. And in VAERS, the good news is you get this rapidly detect safety signals, meaning it's looking all over the place for those VAERS types of reaction. And in that situation, in the VAERS situation, what you're getting is a big safety net that looks at everything. Now remember, not everything that's reported is a side effect, because this is a wide open net. So there could be people who come up and say, I got sick from the vaccine, right? Well, it may be from the vaccine, or it may be something concurrently. So it takes a while to understand how often are we seeing that, right? CISA, right? This is 7 participating centers that does clinical research, takes special calls, looks at vaccine profiles, looks at side effect profiles, and tries to determine whether or not there's really a reaction there happening, right? And the CISA project it really looks at the ACIP guidelines also, because those don't cover these things as well. So it's another way of trying to garner any idea. And last, the vaccine safety data link, right? So this is the one that has 9 integrated healthcare systems and has over 12 million people. Now, you'd say, wow, that's great. They're all linked to get a lot of detail. True, but look at this. Klein and JAMA looked at 10 million of these people and found no data for increased risk of any serious side effect. Yet, there were some, right? So it gives you an idea how vigilant you have to be, how you have to look at so many different ways and so many different mechanisms to decide if something might be operating there, right? Now, variants, right? So everybody's heard about the variants, and obviously everybody's talking about Delta, and certainly that's the biggest one. If you look at the data in the United States, look here, right? You start seeing like, oh my gosh, the Delta is really the one way on top of this that's pushed the others out of the way, and that's important to know, right? And I'm going to talk about variants again later, but please keep in mind, this is going to be an ongoing discussion of variants, right? Now, when they talk about evidence for monitoring vaccine efficacy, we talked about that briefly before, right? Does the correlation of protection exist? Meaning, there are times where you will see antibody levels go up. That does not always mean that you have greater protection. It does not always mean that you're less likely to have severe illness, right? We think it should. A lot of times it seems like it should, but you're getting on very small numbers when you're trying to decide this, right? And we're going to talk about some of those studies. And then sometimes what you see in these trials where everything's very, very carefully controlled is different than the real world. Why? Because in a study, you've got nurses following up on things, you've got researchers watching things, you're checking off all the boxes, making sure that people are very compliant, and all of a sudden, it's a little different in the real world, right? But if you look at the studies, what it shows is that if you have all those different variants, look, beta, delta, gamma, alpha, all these different variants, right? The vaccines are working well. They're knocking these things down, right? And they're doing a good job of helping us be protected, right? To date, we talked about the 18 months duration, 6 months after the second mRNA vaccine dose, and you may maintain longer protection from a more severe illness. In other words, there is some data that if somebody got sick and was very ill, the likelihood is once they recover, they're going to have some very good antibody levels and cellular immunity, right? And when you look at the efficacy studies, look at this, look at this graph. Vaccine efficacy against infection, 91%. Against severe, 97%. These numbers are amazing, right? Moderna, 93%, right? These are huge numbers, right? Great levels of protection, right? Here's another one, right? The vaccine efficacy against the different variants, at least 85%, right? These are very high numbers, higher than most of the usual vaccines we ever see, right? Very helpful to know, very good to know. We do know with the Delta variant, it's nearly twice as contagious, right? So we know that that started elbowing everything up. But remember, it's very important. Remember this. Look. Spike protein has 100 epitope. What does that mean? It means that the protein, the spike protein, which is the one we go after, has 100 different spots on it that are kind of unique. And that when you get an infection, you will get T cells and antibodies that attack all those different sites, right? Delta only has 13 mutations out of 100. So therefore, if you've had the real infection or you've had the vaccine, then you're going to be overwhelmingly protected from this particular variant just by the very nature of how much of that spike protein is still the same, right? And when you look at some of the studies, again, Israel's really been a leader in the world on this stuff, looking at risk infections and such, and they were first to say, hey, look, in this Delta, we think we're seeing a big drop-off in effectiveness of the vaccine, right? Well, that's true. There was probably some drop-off, and indeed, one of the reasons they looked at that is they said, hey, maybe this has to do with how much you space the vaccines, right? Because in other words, everybody said, oh, you're supposed to get this 2 weeks apart, 3 weeks apart. But it turned out that in some situations, when there was limited vaccine, and they weren't able to stick to the schedule. And instead of being 3 to 4 weeks apart, it was 5 weeks apart. Guess what happened? It turned out that when you had slightly greater spread between the shots, you probably got a better response, right? And so that's something to keep in mind. But most importantly, I want you to look at this, right? There are vaccine breakthrough cases, okay? That's going to happen, right? But look, as of August, we had 164 million fully vaccinated in the US. There were 7,000 hospitalizations and 1,500 deaths from vaccine breakthrough, okay? Thus, your risk of death is 0.001% of all vaccinated people, right? This is minuscule. I'm not saying it's nothing, but you have to understand that, because when you start talking about a third dose or immunizing kids, right, then there's a difference in the equation, right? Because these people, the majority of them, 74%, were greater than 65 years old, right? This is an illness of the very elderly, right? And so we need to know that, right? It's not like flu. Flu is equally opportunistic to the young and the old, but not corona, right? And vaccine does work on the variants. If a vaccine is 90% effective, you still have to vaccinate 55% of the population, right? Studies have shown that those with natural immunity, if you had the original infection, you are equal, if not higher protection than those who get a vaccine, right? So this is something that doesn't get discussed a lot, but should be. And if you've had the real infection, I still say to my patients, get the vaccine. Why? Why do I say that? Because you know what? In case your little variant had slight variations compared to some of the other circulating variants, or compared to what a vaccine covers, what the heck? You get a little bit of extra boost. I'm okay with that, right? I think it's a good move and I like it, right? Chinese vaccines don't seem to work as well. Also, another one, I was mentioned this once before, I was a little bit wrong. I thought that J&J was going to be the way to go for my young ladies. Only one shot, older technology. Turns out the mRNAs are probably safer. J&J had a rate of 6 in a million of clotting problems. And now we have good safety studies for the mRNAs for young men, young women, and then we would expect that. By the way, one other point I want to make. It is normal for the antibodies to wane over time. Okay, that's normal. That's always been true in history. That's always been true with every infection we've ever had. You get sick, you develop antibodies, and over time, they go down. If you didn't lose antibodies from every infection you've ever had, your blood would be like bricks. There'd be no way for it to move. It'd be so packed full of antibodies. So it has to wane, right? That's why those T cells and B cells are key. Those are the ones that keep the memory alive, keep things going, and really are helpful to people to make sure they know what's going on, right? We talked about previously cold storage has allowed modifications to make distribution better. And again, the J&J AstraZeneca are okay vaccines. They're probably not as good as the mRNAs, right? You can wait after infection, take the vaccine. 28 days if it's mild, 90 days if you're hospitalized or got IV treatment, okay? So keep that in mind. If you had the infection, but you want to go take the vaccine, wait 28 days or 90 days if you had a severe infection, right? Kids. Kids less than 12, I want to be honest with you. Make sure that everybody has an honest discussion. If you're a kid, you are more likely to have a negative outcome from a vaccination than from getting the real infection. Okay, this is very important. There's risk of myocarditis. There's smaller, less serious risk, but it can happen, right? And kids are 1/3 as likely to get the infection, 1/2 as likely to spread the infection. And there's multiple ongoing studies of kids, but you have to be honest about this. You have to say, look, I'm immunizing kids because I want to cut down transmission through society. Well, okay, that's potentially reasonable. But, again, if the kids are not with elderly people, don't live with their grandparents, don't live with somebody who's sick, you have to be honest. They're likely not going to be spreading it to anybody at risk. And the people who are at risk, that's where we should be putting all our efforts and energy anyways, right? 40% of hospitalized breakthrough cases are immunocompromised. So this is happening to the very elderly, the ones that are immunocompromised, right? Maybe at most 10 to 20% of hospitalized patients had a vaccine. The vast majority did not. 99.5% of all deaths are unvaccinated, or not fully vaccinated, right? So some people just didn't get around to it. Peltzman effect. What is that? What happens is when people get a shot, when people go on a statin for heart disease, when people go on a blood sugar medicine for their diabetes, they alter their behavior. They say, hey, I had a shot. I don't have to be as careful. They say, I take a statin. I can eat whatever I want. Well, I like sugary desserts because now I'm on a medicine for my diabetes, right? So people change their behavior, and that's why some of the risks can change, right? In the UK, as an example, only 0.5% of deaths were fully immunized, and the average age was 84, right? So I'm telling you, these shots work tremendously, right? And that's what you need to know. Israel, okay, Israel has provided a lot of study. Israel was with the Pfizer. They are the ones that documented that drop off in antibody levels and said, we want a third shot, okay? Well, let's be honest. 5 in a million get myocarditis or pericarditis, okay? You just need to know that, right? It's an inflammation of the heart and the sac that goes around the heart. It's more common in younger people. Again, why be hesitant about giving a third shot to young, healthy people? Why I'm particularly hesitant about the kids? And when they say, you'll see it in the literature, there's a 9-fold number, meaning that this third booster shot dropped the risk 9-fold. That's true. But what they don't emphasize is that you started out with millions of people, that the ones that actually had breakthrough infections that were serious were in the 200 to 300 range. And so when you look at a 9-fold reduction, you're looking at about 30 people out of millions. So what happens is the reliability of those statistics gets very limited, right? Another complication, Guillain-Barré, that's a neurologic condition, happens anywhere from 1 to 6 in 100,000 with the shot. Again, this is why I have some concerns, right? And so you have to be honest about that information, about where is it and what's it doing to people, right? Next. By the middle of 2021, based on blood donations in the United States, 83% of the US population has evidence of antibodies, either from natural infection or vaccination. 83%. So we're kind of already there, right? And I admit that there was a reduction in Israel, but again, it was a reduction based on very small numbers, right? There is some data that if you take this vaccine, it may help prevent long-term COVID. That's good to know. Those are the people that have long-term symptoms after it. And booster, again, probably not needed if you have the real infection and completed the 2 vaccine dose regimen. I think for those people, no chance. I wouldn't do it. Look at this efficacy of preventing the disease. In this study of Moderna, 93.2% efficacy, incredible numbers. Look at this study, Moderna from severe disease, 98.2%, right? Incredibly high numbers, right? Look at both of them next to each other, right? They both seem to have equal benefit for participants, equal benefit in age groups, equal benefit of protecting people. That's important to know. This is a busy slide, I know that, but please keep in mind what I'm talking about there is that you're now having these third doses and you are seeing the bump up in the antibody levels. No question about it. And it doesn't matter how old you are. Everybody gets it, right? But a couple of things. Look at the number of participants, very low. And secondly, the big question, does this definitely mean that somebody's going to have less risk of a severe outcome? Maybe, but that's questionable in some situations, right? So if you go to the drug companies, Janssen, they're going to talk to you about how great their product is, right? And how the booster doses can be so beneficial, right? And they'll talk to you about why those booster doses can be provided and can be very helpful. By the way, look. They said a booster dose 6 months provide 12-fold increase, more potent than 2 months, right? That's what we're talking about. That spacing seemed to really help boost them up. Now, on the other hand, the Janssen stuff is really getting boosted up more towards what the mRNAs do, right? So in other words, when they say, hey, look, we gave a booster dose and look at our antibody level. Yeah, it's true. Well, now you've got them more towards what the mRNA does without a booster, right? So nothing against Janssen. It's reasonable product, but keep that in mind, right? So if all these things have these benefits, why am I hesitant to recommend these across the board, right? What's the hesitation, right? So look at the reactions, okay? Pain, fatigue, myalgias, headaches, okay, not too bad. Those should go away. We could deal with that. All right, that's what you get when you take a vaccine. I get it, right? When you look at Janssen AstraZeneca, then you start getting these reports of clots and low platelet counts. And how often? 15 cases per million, 1.9 cases per million, okay? Not a lot, but there were 66 deaths after the first dose, 6 deaths after the second dose. So you better tell me that there's a very good reason that you're going to give this vaccine again, especially a third dose, right? I get the trade-off. When it's the first time somebody needs to be protected, I definitely get the trade-off. And somebody's elderly, immune compromised. But again, when you start talking about booster doses, here's some hesitation. Look. Reports of death to VAERS following the dose 3 of the mRNA or dose 2 of the Janssen COVID vaccinations. Between them, there were 30. Okay. Now, what's the median age? 79 years old, right? And so this is worrisome, right? So do I want to know that this can happen? Yes, I do. Do I think that it's common? Hard to know right now, but picking up this many this early in the third dose regimen is a little bit concerning. And most importantly, was the third dose given for a very good reason? If they're elderly, if they're very sick, I get it. But if somebody's younger, healthier, right? I don't get it. I don't get it yet because I don't think it really translates into meaningful outcomes, or certainly, you're more of a risk, especially if you're a young, healthy kid, of getting a bad reaction to these vaccinations than you are of getting a bad problem from the real infection, okay? So this will be continued to be followed by Janssen, where they're going to follow the FDA and the CDC looking at those side effects that we've talked about, right? Myocarditis and pericarditis, right? We talked about that, right? The inflammation of the heart stuff, right? Mostly younger people, males more than females. But again, you want to know if you're giving this vaccine for a good reason, right? There were other studies that looked at this and said, look, about 10 cases per million doses, right? Like 1 in 100,000, and greater than 100 cases per million doses of these reactions, right? So these numbers are big numbers, right? Compared to how many would actually get into significant trouble if they didn't have a third dose, right? That's why we always have to think about this, right? Reports to VAERS, the system for the third mRNA 2-dose Janssen. Look. Serious report, 6%, 6%, right? I just showed you percentages of, 0.001% of risk of serious infection or death if you've had the vaccine. Well, this is much greater if you're taking a third dose. So you got to know, are you doing it for a very good reason, right? Mix and match. People talk about, well, if I had this vaccine, can I take that vaccine? The answer, bottom line, on this one is yes. But to be honest with you, look at the numbers. Numbers are still relatively small in these sample groups, but nonetheless, I do think it's totally reasonable. But there are some limitations. These are not randomized trials. It was not designed to compare these things. And whether or not this truly correlates with protection, hard to know. If you look at the recommendations, so here they are. So the FDA use for the Pfizer, which is now called Comirnaty. Why? Because it's now approved, right? It's no longer emergency use authorization. It has full licensure for the primary series, 2 doses at 0 and 3 weeks, right? And then there's some emergency use for some other series that can be thought about, right? The third dose booster, all that kind of group, right? Also, for that booster doses, generally, persons greater than 65 years old, right? Persons 50, 64 with underlying medical conditions should receive a booster dose. Other people may receive a booster dose, but keep that in mind, right? I really want to know, am I doing it for a very good reason? Am I really protecting somebody for a good reason so that the risk of the side effects is worth it, right? Here's the EUA for Moderna, right? So 65 years and older to get that third dose, right? 18 to 64 if you're high risk of severe, right? 18 to 64 if you're frequent institution, right? But again, I really want to know who's the patient. Do they really need it? This is a decision that you have to make with your doctor about these things, okay? Kids, at the CDC, 40% already had evidence of infection. It's rare to get really ill. We talked about that. And why not no shot or maybe just one shot, but certainly not needed for all. Maybe we'll see a coronavirus nasal spray in the future, right? Variants, okay? Remember, there will always be variants. There has always been variants. Every infection that ever existed has variants. This thing is endemic. This means that there are always going to be circulating variants. We're never going to get rid of this. You have to be around this concept that it's already endemic. We're already heavily protected. The vast majority of all these masks, things and stuff are just not necessary, right? The vast majority have now got protection. And yes, there will always be some variants. And yes, there will always be some people at risk, just like influenza, right? Just like every year we lose 80,000 people influenza. Well, we never talked about that, right? But now you see what can happen. The numbers of corona will continue to come down as we've gone about this and as the variants occur, right? The COVID variants can be more transmissible and they may be more adaptable, but the host also adapts, right? In traditional medicine, we identify the risk groups and then go after them. That's what we need to do. We need to be focusing on the people at risk. That's where all of your effort goes. That's where all your energy goes. That's where all your research goes. And not for the majority of people who would otherwise have a mild infection, but it's endemic. And if anything, the sooner you acknowledge that it's all endemic, the sooner you realize that it's just going to circulate, the sooner you realize that the vast majority of people have seen it and are protected, their natural immune systems are going to protect them, and we can have a more normal existence, right? You may hear in the literature about SARS-CoV-2, which means a variant with the potential to cause disease in the future. So they're actually studying other variants, which are not circulating, and the current vaccines seem to cover them. Remember public health response? There's no good data that lockdowns were of any benefit, and there's definitely data that they were of harm. And so, for the small proportion of people not vaccinated, you can recommend wearing masks in crowded indoor public settings, only for those who are really immune compromised. Everybody else really doesn't need it, right? There's been literature that says why the masks are equivocal at best, right? And there is good data on the negative impacts on kids by doing too much masking, too much intervention, and it's very important also when you're looking at testing, when you're looking at reports, you must distinguish people who are sick and die from coronas as opposed to those who had with corona. What I mean by that, what I mean. In other words, every time you see cases are rising, right? Well, the problem is there's a lot of reporting bias because anytime somebody's admitted to the hospital, if they're admitted with a corona diagnosis, the hospital gets more money, okay? Second thing, if they test for corona and they see some evidence of corona, they'll list it, even though the reason they're in the hospital is not for corona. Even if they die and it's not from corona, right? It still gets listed that way, right? So keep that in mind when you hear these statistics being thrown at you. Probably in the future, if there's a different formulation, I think that has a place, right? Just like we do a new flu shot every year, I would be open to that, where I'd say, okay, there's enough antigenic drift, enough antigenic shift, meaning those changes in those viruses. And if there's enough of those changes, then maybe a new formulation makes sense, right? Remember, if you raise the antibody levels, you may increase the proportion of who respond. But nonetheless, we've talked about this, right? We've talked about how more antibodies may or may not represent clear extra protection, okay? Again, I don't recommend it for the general public. If you get a third dose to immune competent people, you start raising antibody levels against ancestral strains. What does that mean? It means that if you keep taking shots of the same type of shot, there is science that says you could develop antibodies that attack your antibodies and you actually defeat some of your purpose, right? So that's why we have to be very, very humble in these things. Okay, 68 billion doses and counting. Operation Warp Speed was fantastic. Really brought us a great response in such a short time. There's intense monitoring going on. The data do not suggest a safety signal or death concerns excessively, but nonetheless, there are some. And that's something that you need to keep in mind and know about it, because that's going to be the thing that's going to influence what should be a recommendation for an individual. Okay, so I know that's a lot of information, and I hope it was helpful for everybody. And I was trying to just get them in as much as possible information as short a time. I hope it was helpful, everybody.